Welcome to Ask and Learn.
So in this problem, we have a 0.3 liter glass of water at 20 degrees Celsius, which is cooled with ice to 5 degrees Celsius. We want to determine how much ice needs to be added to the water in grams if the ice is at 0 degrees Celsius and B negative 20 degrees Celsius. We also want to determine how much water would be needed if the cooling is to be done with cold water at 0 degrees Celsius. And we're given the melting temperature and heat of the fusion ice at atmospheric pressure and the density of water. So we know that the volume of the water is 0.3 liters. The initial temperature of the water is 20 degrees Celsius. The final temperature of the water is 5 degrees Celsius. The density of the water is 1 kilogram per liter. And we're going to assume that the thermal properties of ice and water are constants. Heat transfer to the glass is negligible. There's only stirring by hand or a mechanical device. And the heat of ice is 333.7 kilojoules per kilogram. So for part A, the mass of the water can be defined as the density times the volume. So that's just 1 times 0.3, 0.3 kilograms. And we can take the ice and the water as our system. So the energy balance for the system will be E in minus E out is equal to delta E for the system. So 0 is equal to delta U, the ice, minus delta U, water. So the mass of the ice at temperature initial could be, which is 0 degrees Celsius, can be defined as this. And that's the ice final. This is for the water. Just solving, plugging in. So then we're given that the mass of the ice is 54.6 grams. And that answer was initially in kilograms, but I just converted it to grams. So now for part B, we're going to do the mass of the ice when its initial temperature is at negative 20 degrees Celsius. So take ice 1, so negative 20 degrees Celsius here. So this will give us that so that is for the ice, and now we're doing for the water. And that's equal to 0 because, and these are set equal to 0 because of thermal equilibrium, which is will be reached. So then we can just plug in all of our stuff again, which gives us M ice is 48.7 grams. And again, I converted that to grams from kilograms. So the mass of the cooled water at the temperature of the cooled water being 0 degrees Celsius can be defined as the following. So that's the cooled water versus the water. Just subbing in our formulas for that. Then we can go ahead and plug in what we know, which gives us the mass of the cooled water of 900 grams.